welcome to Full Throttle RC. I'm your host, Tony Castronovo. This is episode number 3, or part B, of our engine modifications. So, join me in a couple seconds and we're going to get into doing engine modifications. New product alert from Warehouse Hobbies and Forcer Manufacturing. Let me introduce to you the EKG. This new electronic device is a safety item that we've just designed for gasoline model boating, and you might have thought on the website we did a preview about a month ago, and they're here and they're ready for sale. And I'd like to show you how they work. This tiny device is a little larger than a quarter, very, very lightweight and waterproof. It plugs between the switch and the receiver of your radio and will work with most J-series connectors. It's very easy to install. There are 2 wires that come off the EKG that get routed out of the radio box. The EKG gets mounted in the radio box, the 2 wires get routed out, and they are easy to hook up. On this Zenoa engine, for instance, we take the black wire, which is the kill wire or the ground wire from the magneto, and 1 wire would hook up to that. The second would hook up to anywhere on the block for grounding. Let me explain how the EKG works. First, the EKG stands for engine kill guard, and that's exactly what this device does. This device monitors the battery voltage between your radio battery and the radio receiver. It also is in line after the switch, so it detects any type of a voltage differential from the batteries to the receiver. If the EKG sees less than 4 volts, it will close the loop and shut the engine down. At worst, if your radio was to lose sudden power, or the receiver was to lose sudden power, such as a bad switch, a bad NICAD, a battery coming out of a holder, or a wire breaking loose, rendering no power to the receiver, the EKG will immediately latch and shut the engine down. This is a great safeguard, and in conjunction with a standard safeguard that monitors radio frequency, you have the best chance of not having an accident occur. The EKG, a fantastic device, on sale this month of December for $39.95. Welcome back. Let's get started. The first thing I want to show you guys is what a degree wheel is, for those that don't know it. Is this, guys, this is the infamous degree wheel. You've heard people talk about it a million times, and some people are too embarrassed to ask about it. It's a simple little tool. And this particular one, and what we need, is clear, and it's available at most good office supply stores. And it is completely round, and it references 360 degrees, a full circle, starting at 0 with increments between. So you want to find a good quality, nice thick plastic one at an office supply store. Stay around 6 or 7 inches in diameter. You don't want to exceed that. It makes it too difficult to work with. Okay, when you get your degree wheel, more than likely it's going to be completely round with no hole in the middle. So you have to find center and drill a hole. And the hole size is according to the size of the crankshaft screw. For instance, if you're making a home light, doing home light work, that's a number 10. If you're doing Zenoa, it's a 6 millimeter. So you want to just about clearance the hole for the screw. Second, it's a real good thing to add a washer in the front and also the back side of the degree wheel. These are plastic. They're not designed to be doing what we're doing with them. And it's important that they're put on the shaft and tightened down so they can't move. So obviously if you tighten down a nut on a plastic wheel like this, it's going to crack. So I glue a washer, a good hard metal washer on the front and back side. Okay, it's very simple. The next thing is the pointer, or the indicator. This is what's going to reference the degree wheel. This is a simple part made out of a 440 music wire, where I put a point on one end, okay, as you can see, and then I mounted it to the block. And it can be mounted anywhere on the engine block. Doesn't have a specific place. And let me explain the most important thing on how to make this particular part. Once you've made the point, you want to install your degree wheel. I'm going to do this really quick as possible, on the crankshaft. And like I said, this is a home light. We're using the home light since I have this cutaway for references. It's easier. And what you're trying to do is you want to establish the pointer under the degree wheel to where you can look at the front of the degree wheel and see the point, which identifies each degree. So in this case, let me show you what we're going to do here. Let me back up and find some tools. Okay. Let's see what we're going to do here. Oh, well, you know what? Better yet, I can push the crank. I want to bend this rod so I can get a good reference point on it. And I want it to be, zoom in here if you can, Chris. I want to keep it about 1/8 inch between the back of the degree wheel and the pointer. The further I get behind it, the harder it is to see, and the less accurate it's going to be to take the measurements. So this is about 1/8 of an inch. I got real lucky that I was able to bend it. And I'm going to get it as horizontal as I can. And this needs to be tight. Okay. That's basically how your degree wheel is going to look when it's mounted. Again, you'll be able to look through the clear plastic at the pointer. If you like, you can do a small red tip on the point. If it helps you, you can do that. But this is basically it. You want it to, and again, like I said, the pointer can be mounted anywhere on the engine. It doesn't matter. Since the degree wheel is going to be adjusted, we'll find 0 anywhere on it. Okay? Okay, let's get started. We're going to need to take measurements to do this. So we need to have a pad of paper and a pen, and then a calculator at the end so we can use our measurements to make modifications. Okay, so that's very important. You'll never be able to remember this, so make sure when you're doing this you have a pen and paper. Okay, the next thing we want to do is we want to set our degree wheel up. And again, we're using the home light for reference because it's easy to see the cutaway. We want to get the piston to top dead center. And that's obviously, we learned that from the first show. That's where the piston stops dead at the top. Is no longer traveling up or down. It's ready to take its downward cycle. Once you've established top dead center, you want to go over and you want to take your degree wheel and you want to line up on 0 with the indicator. So what I'm going to do is just find a 0, which is right here. Okay? And I'm going to line it up to the indicator. We need to make sure the piston stays at top dead center as well. Now you want to hold the crankshaft. You can have a little device that you can use to hold the piston when you're tightening this, because as you tighten the degree wheel, you don't want to turn the crankshaft. In this case, I'm going to hold it very carefully with my hand here, and I'm going to snug it down. This can't change. If this changes, all our measurements are pretty much useless. So again, now we're back at top dead center. Our degree wheel's at 0. And Chris, zoom in here. You'll see the needle underneath the 0 there. And that starts our reference point at top dead center, 0 degrees. All right, now we're going to put on paper what our engine's actually doing or how it works, and the degree wheel is going to tell us. Okay, we're going to be asking Chris to do a lot here. He's going to be panning this camera in and out so we can show you what's going on. We've got our piston at top dead center. Okay, and we're going to turn the engine over, and obviously top dead center, if you look closely, the intake window's open. Okay, again, this is a modified engine. I don't know if I said that. So some of these timings, these are not stock timings. And it's really not relevant to this, so I'm not going to give exact numbers. I don't even remember them on the home lights, to be honest with you. But I'll explain what's happening. We're going to start turning the wheel, and what we're going to look for is the duration that the intake window is open. So we're going to turn it the direction that the engine's running. Obviously, that's very important. So we're going to start counterclockwise, and we're going to start moving it as the piston's going down. Right about there, the window closes. Okay? Now looking back over to the wheel here, we're going to see the changes. We started at 0, okay, and we've moved from this point to this point. So the degrees between 0 here and here is the duration that the intake window was open. That's what duration means. Okay, so let's count it. The degree wheel is in tens and then incrementally. So we'll start with tens and we'll go 10, 20, 30, 40, 50, 60, 70. Then we'll go to the midpoint, 75, and this particular window closed at 76 degrees from top dead center. So now I'm going to go to my pad and I'm going to write intake closes from top dead center to close, so TDC to close. We're going to put 76 degrees. Now, I don't know what it's going to be on your engine or the stock engine, but we're going to use it as a reference, so we know where that is right now. Okay, one more time. Let's do it one more time. We'll go back to top dead center. Always, it doesn't hurt to check your work 3 or 4 times. We're notorious around here for checking our work. Okay, or I'm notorious for checking everybody's work. All right, we started back at 0. We went back to the engine. We've established that we're still at top dead center. We're going to rotate the engine until the piston skirt closes the intake, which is now. As soon as you can't see light, the light's done, you're done. We're going to go back over here, and it hasn't changed. 76 degrees. So that just established the duration of intake timing. Okay, the next ports we're going to look at for duration are the transfer ports. And we talked about those also in episode A. Those are the 2 side ports that are responsible for carrying the oxygen and gasoline up over the top of the piston to get it into the combustion chamber. So we want to know when they open in this case. So again, we re-referenced the top dead center 0. So I made on my pad transfer timing at TDC is at 0. And again, remember we rotate the engine the right way, counterclockwise, and I'm going to turn it until I just see the transfer opening. And that will be indicated at the top of the piston. You'll start to see the window open. Chris, zoom in here if you can. And at this point, if you look way back in there, you're going to see the window just starting to open on the transfer timing. Now, obviously, this is going to be identical to both sides of the cylinder because the transfers are identical on the left side as they are on the right side. Okay, now we're going to carefully, without disturbing anything, we're going to go over to our degree wheel. And we're going to start at 0. We moved quite a bit. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 degrees. 110, 120, 125, 26, 27, about 128 degrees. So now we know from TDC to transfer beginning to open is 128 degrees. And we'll put this on our pad. All these numbers are going to come in handy. Okay. Now let's go a little bit further. Let's continue the cycle, leaving the degree wheel where it is, and let's go down, okay, to 180, which is bottom dead center. Okay? And look at, and this is a perfect way to establish it. This is how you know you're right. Piston's all the way down. The transfer timing is fully open. It can't open any more than this in this particular configuration. The piston's at its standstill point at the bottom. We've gone over to this side of the degree wheel, and now we have bottom dead center, 180, half of 360 degrees. This is pretty easy, guys. I know that it sounded like voodoo science, but it's really, really easy. So at bottom dead center, opposite the top dead center, is 180 degrees, half of the 360 degree cycle of your engine's full circle operation. Okay, the final port that we're going to identify right now is the exhaust port. And this is the port that makes most of the performance. And this is the easiest way to get performance out of an engine is to modify this port. Okay. What we're going to look for is we're going to go back to top dead center and we're going to zero out and make sure our indicator's still on 0. And we're going to turn it and start to open. And we're going to turn it again in the rotation the engine is designed to run, counterclockwise, until the port just begins to open. And that's right about here. So as you look in, you'll see the piston just clearing the top of the port. Now, we're going to start, I like to start at top dead center always. It's just a good reference point. So I'm going to put top dead center to where exhaust port begins to open. Okay? And that particular time, and I'm going to go back over here now without disturbing anything, and I'm going to count it off. And it's 10, 20, 30, 40, 50, 60, 70, 80, 90, 105 degrees. So I'm going to put down 105. So now I know, again, if I was doing an engine, I would check this work a couple times. I know that now from top dead center, if I go back to 0 and I go to where the port just begins to open, it's 105 degrees. Okay, now you could get the duration of the entire port at this point too. You can continue the rotation, okay, until the port closes, or you're at bottom dead center in this case. Again, this was a modified engine, so we set our engines up to where there's no interference between the porting and the piston. When that piston is at the bottom, that port's open all the way. There's no casting That's part of the engine work that we'll go into later on. Okay? And you can do reverse if you wanted to. You could start at bottom dead center at 180 degrees and work your way back up to get the duration of the port size. Watch, from 180 degrees until it closes. And then go back over here, and you'll be at 100. Okay? So you can start at bottom dead center, you can start at top dead center. I like working off the top, and I use those numbers all the time that way. So this port again, we go back to 0. We come down with it till it opens. Okay, it opens at 105. We write down 105 and establish. What we're doing here is we're establishing the timings. We want to establish the timings on a stock engine. We want to know where the manufacturer designed this engine and what port timings they used. Then we could start. This will determine on what type of work we can do and where to start. Okay, so once we have this all, because you have to have a baseline to start, or you don't know what you did right or what you did wrong. Okay, so we've established the 3 of the most common things we need to know right now. We need to know the intake duration, the transfer duration, and also the exhaust duration. Okay, and that's what this did. Very simple to hook up a degree wheel. Now, what I'd like you guys to do at this point, we don't have to get too far into depth with engine modifications right now. Why don't you get your degree wheel set up? Take one of your old engines apart, or take a good engine, take the spark plug out. Get a degree wheel on there, put your indicator on there, and start getting establishing stock timings. Then when you go on the internet or you're talking to somebody and they start saying, well, the exhaust opens, or it opens at 189 degrees, then you know what they're talking about. They're basically, and then when you compare it to your stock engine, let's say your stock engine is, these are all fictitious numbers, let's say your stock engine is 170 degrees. Well, if they're telling you that they've modified the window to 189 degrees and you're at 170, that means there was a 19 degrees change in the window, the height of the window. So that's very easy to establish. You use your degree wheel to establish 19 degrees. You make your cuts, you use a Dremel tool, you grind the port up high until you ground it to where you put it back together, it's 19 degrees. And this sometimes takes several times putting an engine back and forth. And a guy in a shop, this is how you do it. In our case at Warehouse Hobbies, we have the machinery program for all this. We dial in numbers into the CNC machines, and even on our hand machines, we have jig fixtures and dial indicators all set up on the equipment. So we just punch in a specific number, and it tells us where to go, or it stops at a particular point so that no mistakes can be made. But since you're doing ones and twosies in your shop, this is the right way to do it. And it's very good to educate yourself with this, where you're using your degree wheel, you're making incremental changes, you're putting the engine back together. If you've gone a little bit, you don't want to go a little bit too far, guys. Always a little bit at a time. So if you had to make a 19-degree change, you want to make, you basically want to take a little bit, put it back together, catch it within a few degrees, and then get it exact. And that's how you do. That's called hand porting, and yet that takes a considerable amount of time. But the more time you spend to match those numbers, the better your engine's going to run. Soon we're going to get into what we actually do, and it gets a little bit more in depth. So I really want you to understand how your degree wheel works, and actually go put one on an engine and really work with it. Write the numbers down. Then start talking to some other guys, or go on the internet and get the numbers, and you'll start to understand what it means between a stock set of timing and a modified set of timings numbers. And then you'll understand, in the first segment of the show, we explain porting. So tie that all together. And what we've done to ports, we've raised exhaust, we lower intake, we raised transfer timings. Pretty basic and simple. It gets a little bit more involved, but this will give you an idea of how to get started the right way. Okay, so go out and get yourself a degree wheel, get it hooked up, set it up right, start learning about your timings, write it down, understand what you're doing, and in this next segment, episode number 4, which will be segment 3 of this series, we're going to really get into some hands-on machine work and port work and show you how to set that up so you can make successful racing engines for your model boats, or fast sport performance engines, I like to call it. Thank you for joining us. My name is Tony Castronovo. This is Full Throttle RC presented by Warehouse Hobbies. Thank you.